topic is proving triangle congruence. Before we proceed on proving using two-column proof, let us consider these reasons for indirect information. Number one, definition of midpoint. So when we say midpoint, that point, example, if this is point A here and point B here, the midpoint is the center. Okay? If I have to name this midpoint point C. Therefore, considering that this is midpoint, we have in mind that there are two segments to be equal, right? So, we have line segment AC is congruent to line segment CB or BC because of the reason that C is the midpoint. That is the use of definition of midpoint. So, when there is a midpoint, take note that that midpoint divides the line into two equal segments. I hope that is clear. Let's proceed to number 2. Definition of bisector. From the word bisect. So, bisector divides a part into two equal parts. Example, if we have this line and we will name this line AB, and there is a line bisector. Okay? We call this perpendicular bisector. So, this perpendicular bisector divides this line into two equal angle. So, we have 90 degrees angle here and 90 degrees angle here. That is definition of perpendicular bisector. Now, what is this one? Definition of angle bisector. When you say angle bisector, if this angle A, B, C, for example, then there is an angle bisector. Then this angle bisector divides the angle into two equal angles. So, if this angle ABC, if the measurement of angle ABC is 60 degrees, then this angle bisector divides 60 degrees into two equal angles. Therefore, there is 30 degrees here and another 30 degrees here because of the angle bisector. I hope that is clear also. Now, definition of vertical angles. Last time we discussed about vertical angles. So when two lines intersect, then there are a pair of vertical angles which is congruent. So if this is 60 degrees, this must be 60 degrees. And to complete the 180, this is 120 degrees and the opposite also is 120 degrees. These angles here and here are equal and said to be vertical angles. This angle here and here also are equal and said to be vertical angles. That is definition of vertical angles. Now let's proceed to number 4. When we say reflexive property, that will be like this. For example, if this is a triangle, then one side here, triangle A, B, C, and this side here, BD, can be BD is equal to or congruent to BD. Okay, if we are going to separate the two triangles, we come up with this triangle here and this triangle here. This one is A, B, D, and this one is B, D, C. So, therefore, by reflexive property, we have BD is congruent to BD. So, the reason is they are reflexive. Okay? So, when you can say, example, AC is congruent to AC, then the reason is reflexive property. Take note of reflexive property. Next, we have the so-called alternate interior angles. So take note, alternate interior angles are congruent. Even though alternate interior angles occur, saan ni siya matabo? When we have parallel lines. Okay? When parallel lines cut by a transversal, then alternate interior angles are congruent. If this is angle 1 and this one is angle 2, therefore angle 1 and angle 2 are said to be congruent because they are alternate interior angles. If I have to assign this as angle 3 and this one is angle 4, therefore angle 3 and angle 4 are congruent because they are alternate interior angles. Number 6, the property of parallel lines. So we have the property of parallel lines. Therefore, when a parallel line cut by a transversal, we have alternate interior angles are congruent. Now that we knew these reasons, we are now ready to solve or prove triangle congruence. Okay. So let us try this example. Okay. So we have this example. Okay. And this example. Okay. So we have A, B, C, and F, E, E, D. Okay. The given is AB is congruent to DE. Okay, and angle B is congruent to angle E. Another given is BC is congruent to EF. Now, we're going to prove that triangle ABC is congruent to triangle FED. Now, the first thing is we need to consider this given information. Now, first we're going to mark the given information. AB is congruent to DE. So, this side here is congruent with this side. Okay? Next, BC is congruent to EF. BC is congruent to EF. This side here. Now, angle B is congruent to angle E. So, angle B is congruent to angle E. So, if we're going to make a two-column proof, okay, we have the statement and the reason. Okay. First, we are going to write all the given information. So we have AB is congruent to DE. Next is BC, number 2. BC is congruent to EF. Number 3, we have angle B is congruent to angle E. By the way, we're going to write first the angle. Angle B is congruent to angle E. Then number 3, BC is congruent to EF. Now we are going to prove, number 4, that triangle ABC is congruent to triangle FED. Number one is, the reason is, this is given, right? Information. Number two is still given. Okay? Number three, the reason is given. Okay, very easy. And number four, now that we have the three informations available, this AB and DE is a side, right? AB and DE, that is side. Angle B and angle E is an angle, okay? Side BC and side EF is an angle also, is a side also. Therefore, triangle ABC is congruent to triangle FED by SAS postulate. Okay. Now that the information is complete, SAS, then we can prove that these two triangles are congruent by SAS postulate. Now we are going to label this one. This is side, this is angle, this is side. The other one, this is side, this is angle, this is side. So SAS. So by SAS postulate, then these two triangles are proven to be congruent. Okay, let us consider this next example. So we have two triangles here. Okay, we have triangle NER and triangle VNR. The given information we have is angle NER, okay, NER, this angle, and angle NVR are congruent. And here comes bisector. RN bisects ERV. This RN is the angle bisector of the angle ERV. Now we are going to prove that triangle NER is congruent to triangle VNR. Number one. First, let us consider the given information. You know what? In order for us to solve a certain problem or case, we need to consider first the given information. We have to gather the information which is already given. So we have the given information, so we will write angle NER is congruent with angle NVR. What is the reason? The reason is given. Okay? Number two. What do you think is number two? Number two, we have here this angle, right? Okay? That angle. So we have angle ERN. ERN is congruent with angle VRN. VRN. What do you think? What do you think is the reason? The reason is, since we have that bisector, therefore these angles is divided into two. Therefore, our reason is definition of, okay, definition of angle bisector. Now, we have used this definition already. Definition of angle bisector. Number three. Number three, what do you think is the common? Okay, what do you think? So we have another one. We have RN is congruent with RN, right? side Rn is congruent with side Rn. If we are going to separate these two triangles, they have common side which is Rn, and Rn is congruent with Rn by reflexive property. Okay. Now, since we have angle, side, then number 4, we can now write this proof statement. We have triangle LER is congruent with triangle VNR by AAS postulate. Okay, look at this. Angle, side, postulate. That's it. Okay, we have here another example. So we have this figure. There are two triangles here. Okay. The given information we have is BC is congruent with CD. And line segment or side AC is congruent with EC. First thing, we're going to mark the given information. So we have BC is congruent with CD. And also AC is congruent with CE. Okay? Then we're going to write this information here. Now, first is BC is congruent with CD. The reason is given. Now, as you can see, based on the figure, that refers to BC and CD, and this is side. Okay, we'll mark that as S. Now, side, then what's next? We need an angle. Okay, because we have this given side also, right? So we need an angle, and very clear that these angles here are said to be equal. Okay, so we will write that angle. Angle BCA is congruent, that refers to this angle, with angle DCE. DCE. What is the reason? The reason that they are vertical angles. So that your reason here is definition of vertical angles. Take note, since they are vertical, they are said to be congruent or equal. Now we have S, we have angle, we need one side. And again, one side is given here. So we have AC is congruent with EC, and that is given. Then for number 4, we have triangle ABC. This triangle is congruent with triangle EDC. EDC. Sorry. And the reason is by SAS theorem or postulate. That's the same. SAS theorem. Okay? Side, angle, side. Side, angle, side. Side, angle, side. So we have proven that by SAS postulate that triangle ABC and triangle EDC are congruent. Okay, we have another examples here. We have this figure, triangle GFH and triangle IFH. Now we have the given information. Angle G is congruent with angle I. So we will mark the congruent parts. This is angle I and angle G are said to be congruent. Another given information is if H bisects GFI. Take note, the word is bisect, therefore there are angles which are congruent. Okay? Now, we will write this. We have angle G is congruent with angle I. The very reason is given. What's next? This is angle, right? So, next is we have another angle. So, what do you think? We have this angle here and here, right? These angles. The reason is definition of angle bisector. Since if H is angle bisector, so this angle is divided into two parts. So we have angle GFH is congruent with angle IFH. GFH is congruent with angle IFH. The reason is definition of angle bisector. Because of this angle bisector, then the angle GFI is divided into these two congruent angles. Number 3. So we have one side here, one angle here, okay, and another angle here. What we need is one side. What is that one side? Okay, so very clear that that side is FH, right? FH is congruent with FH. If we are going to separate these two triangles, they have a common side, FH. Maybe the triangle will look like this, okay? The other triangle will look like this. This is F, G, H. This one is I, F, H. They have common side, FH is congruent with FH. And the reason is reflexive property. Here, reflexive property, number 4. So we have A, and S. Therefore, number 4, we can write the proof statements. We have G, okay, triangle GFH is congruent with triangle IFH. The reason is angle, side, postulate or theorem. When you write postulate, that's right. When you write theorem, that's right. So we have angle, side, postulate. Okay, let us consider these two problems here on the board on proving triangle congruence. So we have here, okay, triangle SRT and triangle UTR. The given information we have is ST is parallel. This symbol is parallel. So ST is parallel to RU. That is why we have an arrow here that refers to ST is parallel to RU. Okay. Now we are going to prove the triangle SRT is congruent with triangle UTR. Take note. Okay? Take note that this line here are parallel and we have a transversal. So when we have parallel and a transversal, then we have in mind that alternate interior angles. First is we are going to have this angle R is congruent with angle T. So we have angle SRT that refers to this angle. SRT is congruent with angle RTU. RTU. The reason is, what is the reason? Alternate interior angles are congruent. Okay. Alternate interior angles are congruent. Number 2. We have angle here, right? And this angle here. Number 2, we have RT is congruent with RT. That is very clear that RT is congruent with RT. Very obvious, right? The reason is reflexive property. Okay? Number 3, can we have another angles or side which is congruent? Take note, if these lines ST and RU are parallel, then alternate interior angles are congruent. So this is not the only angles which are congruent, these angles also. Will you agree? These angles also are congruent because they are still alternate interior angles. So we will write that angles. So we have angle STR is congruent with angle TRU. The reason is the same, alternate interior angles are congruent. Okay? So we have angle here, side here, and angle. So to complete, we have ASA. So we'll write now the proving statement. So triangle SRT is congruent with triangle UTR by ASA or ASA postulate. Okay, let's proceed with the last example here. Given is angle W and angle Y are right angles. So we'll mark here right angles. Therefore, if this angle W and angle Y are right angles, then we can say that these two triangles are considered to be right triangles. Okay? Now, another given is X is the midpoint of WY. Now take note, since because of the word midpoint, X is the midpoint of WY, then this midpoint X divides the WY into two equal segments. So we have WX and XY. And another given is VX is congruent with ZX. So we have VX is congruent with ZX. First, we're going to write the given. Angle W and angle Y are right triangles or right angles. The reason is given. Okay? So, we'll write again, angle W is congruent with angle Y. The reason is definition of right angles. Okay? Therefore, triangle, okay, VWX and triangle, we will use and ZYX are right, okay, please complete this one, triangles. Okay? The reason is because they have one angle which is right angle. Okay. Number 4, we have WX is congruent with XY, the reason is definition of midpoint with respect to X. Then another given is VX is congruent with ZX. The reason is given. Okay. Now number 6, we'll write the proof statement. We have triangle VWX is congruent to triangle ZYX. The reason is the HL postulate. When we say HL postulate, this is only applicable if the two triangles are right triangles. That is why in our first statements, the 1, 2, 3 statements, we prove that they are right triangles before we come up with HL postulate. Because again, HL postulate is only applicable for right triangles. So WX and XY is the L, okay, and VX and ZX is the H. That is why by HL postulate or LH postulate, we have the hypotenuse and one side the leg. Hypotenuse and the leg. Hypotenuse leg postulate. So we have proven that these two triangles are said to be congruent by HL or hypotenuse leg postulate.